Okay, everybody, so I thought that I would do a couple of extra examples on rates of change, slopes of tangent lines, things like that, so that we could see just how the process works just a little bit more. I have the function y equals 1 minus x cubed here, and I'd like to draw a couple of tangent lines to it if I may. I'd like to draw the tangent line at the point 1, 0, and I'd like to draw the tangent line at the point 2, negative 7. The point 1, 0 and the point 2, negative 7. And what I'd like to do is I'd like to find the slope of the tangent at 1, 0. And then the slope of the tangent at 2, negative 7, but you'll get the idea. So the way we do that is we pick the point in question, 1, 0, and then we come over here on the line and we pick 1 plus h. We just move over to the right by, oh, ever so little. H is a very small positive quantity, and the y value would be whatever f of 1 plus h is. And what we do is we find the slope of the line between those 2 points. And then we decide that we're going to let h get very, very small. And if we let h get very, very small, that moves the second point so close to the first point until the two basically become one in a beautiful ceremony surrounded by family and friends. So, algebraically speaking, let's crank it out. The slope of the secant line, the line that actually passes through those 2 points, is the change in y over the change in x. Well, the change in y is f of 1 plus h minus 0. So f of 1 plus h is what I get when I substitute 1 plus h in there. That's 1 minus the quantity 1 plus h cubed. F of 1 plus h minus f of 1 divided by the change in x. Well, 1 plus h minus 1, well, that's rigged. So then all I have to do is know a little bit about the binomial expansion theorem or do a whole lot of expanding the brackets. And if I do, then all sorts of stuff cancels out and simplifies and you divide by h, and I'll let your algebra work that out. But that all simplifies to negative h squared minus 3h minus 3. That is the slope of the secant line. So if I were to choose as my other point 2 comma something, then h would be 1, I'd sub 1 in for h, and I'd be good. Now, I'm not interested in the slope of the tangent. I'm interested in what happens as h gets closer and closer to 0. Because as h gets closer and closer to 0, the slope of the secant becomes the slope of the tangent. And as h gets closer and closer to 0, this gets closer and closer to 0, this gets closer and closer to 0, that's all that's left. The slope of the tangent line is negative 3. And then we can do the same thing for the green line. The slope of the secant is the change in y over the change in x. So we pick our point 2, negative 7, and then we pick some other point that's right near it with an x coordinate of 2 plus h and a y coordinate of whatever f of 2 plus h is. So f of 2 plus h is what I get when I sub 2 plus h in there. That's 1 minus 2 plus h cubed. And then this y value is known. And so I do a lot of algebra, and I expand the brackets, or I use the binomial expansion theorem, or I do something that cleans that up. And a whole bunch of h's cancel out, and you end up with negative h squared minus 6h minus 12. Now we want to know what the instantaneous rate of change is, so as h gets closer and closer to 0, the slope of the tangent happens to be negative 12. And that would be the slope of the tangent at 2, negative 7. Okay? Okay. Now, if I want the equation of a tangent line, Well, the equation of a tangent line is easy to find. The equation of a tangent line can be found fairly easily because I know that the equation of a line in point-slope form is y minus a particular y value equals the slope of the line times x minus an x value related to that y value. So in this case, my x value and my y value are known, and my slope is known. And so I can write the equation of the line very, very easily. So if you want a little extra practice before you do the stuff from the textbook, you can take a look at these two curves right here, and you can find the slope of the tangent line to y equals x squared minus 2x at the point 3, 3. You could find the equation of the tangent at 3, 3. And over here, we could zero in on the point 2 comma 1/2, and I could ask for the slope of the tangent line at 2 comma 1/2. Now you can hit the pause button and go to town on those, and in about 10 seconds of actual time, I will reveal those answers. Okay, so the equation of the tangent line is y minus 3 equals 4 times x minus 3. Hopefully you at least got those 3's right, and then the slope. And that makes sense. Line looks like it's got a slope of about 4. And then over on the right side, the slope of that tangent line is negative 1/4. And again, that sort of looks like that makes sense. The line's got a slope of about negative 1/4. Okay, thanks everybody.